Good afternoon, everyone. Welcome to today's webinar entitled What is Circular Economy in Construction? Today's webinar should last no longer than an hour. And today we have two speakers, Dr. Paul Toyne, who is an independent strategic sustainability advisor, is going to be talking about what is the circular economy in construction, and then Julia Messenger, a sustainability advisor from BAM Construct UK, will be speaking to us Thinking Circular at BAM Construct. Just a few admin points. You can submit questions through the chat or question box, and we'll go through those at the end of the presentations. If you could remember to tell us who you are directing the question at, and I will read through the questions and we'll do a Q&A at the end of the presentations. Should also say they just started digging up the road outside our office, so I hope the noise isn't too disruptive. We've found a quiet room here. So just a few other things before we get started to make you aware of. We have run a few other events on circular economy here at Syria this year. We held a one-day conference on circular economy and material resource efficiency in construction, and we have a couple of seminars coming up. Designing and delivering a circular economy for road and rail infrastructure at Syria's offices in Barbican, London, in partnership with Temple on the 12th of November. And on the 22nd of November, we have another event implementing circular economy in the water sector. So if you would like to attend either of those events, then you can register on the website. And that's really all that I'll cover before I hand over to Paul Toyne. So if you just bear with us while we hand over to Paul.
Good morning, everyone.
Hi, Paul. The control is now with you.
Wonderful. Let's see if we get the technology to work.
Perfect.
Let's just go. Wonderful. Okay, well, welcome everyone. My name is Paul Toyne, and I kick off the first part of this session. And what I'm really looking to do, first of all, is to give you a better understanding of what some of the drivers are around the need for a circular economy in construction. And I'm going to assume that the basic level of understanding is pretty minimum. So you've joined, so you want to get an understanding of that. And then I'll go into the principles around the circular economy and leave with some examples and hand over to Julia. Just by way of background, I trained as an environmental scientist. I'm an ecologist. I've done a number of different roles throughout my career. I've been a conservationist and campaigner with WWF, helping to establish things like the Forest Stewardship Council. I've also worked in the area of corporate social responsibility, setting up my own a business, a consultancy, working for the likes of construction, utilities, retail, a whole variety of different businesses. And more latterly, I've had a number of corporate roles as a director of environment and sustainability, Ovis Lease, WSP, the design and engineering environment consultancy, as well as Balfour Beatty. So I've got a broad background both in vertical development in terms of buildings, but also in infrastructure. So what do I do now? I'm a non-exec for a building services business. I have a variety of different commissioner type roles, providing strategic advice to public sector bodies. And I also work in the private sector, providing advice on a whole array of things, which vary between the circular economy materials through to climate change, resilience, natural capital, but a lot to do with placemaking. So how do we bring all this together to develop and deliver a quality of life for citizens around the built environment, incorporating infrastructure as well. And finally, and I do enjoy doing this, I do a lot of facilitation and chairing of conferences. So that's a little bit about me. So what are you going to get out of today? Hopefully the bigger picture first, and you'll understand maybe from what I've just told you about my background why I will talk about ecosystems and environment as well as being important to the circular economy. It's not just around the technical abilities of how we mine our materials. Explain those different business models and then hand over to Julia. So You've probably seen something, slide like this before, and it really just puts into context, what have we got? Population growth, consumption increases, whilst finite resources reduce, and this creates problems. It also creates opportunities. Most of you are built environment professionals, and you're well aware of this phenomenon of urbanization. It's not just happening in developing countries, but it's also happening in the UK, where we've got a growing population. We have to improve our infrastructure, but we also have to increase the number of housing, and we are creating new garden towns, for example. So we have to provide a new system to cope with these particular pressures. And when we look at the population levels, we also have to understand how the biosphere has changed, and land use patterns and changes do also affect the circular economy. And I will be referring back to that in a moment. But no surprises, you're probably all very familiar with the reduction of rainforests, for example, the increase in desertification, for example. And all of these things are driven by our desire for consumption, which is stimulated by population growth. And if you're not aware of some of these publications, the first one I've got here is about biocapacity and our ecological footprint. So, you know, people are now the major planetary force for change. You know, if you just think about it, around 60 years ago, our global population was 3 billion. Look what it is now. And actually, at around 1990, we hit a tipping point, almost like a breaking point, which was signaled by cod fisheries decline, Baltic Sea algae blooms due to acidification. And basically, we're filling up our planetary space, and we reach saturation of the biophysical capacity of Earth. And the graph, or the schematic in the right-hand side, really looks at these 9 planetary boundaries. And actually the areas in red around climate change, around our nutrient cycle like phosphorus and nitrogen, and understanding our biocapacity is a big issue. So we've got a lot of data now in science, and also you'll be familiar with the terms of ecological footprints, you know, in the statement of how many planets do we need to sustain a Western lifestyle. Likewise, there's the shut-off point every year, which is getting closer to January, where we use all our resources. So I think it's around sometime in August now. So in September, October, November, December, we're now living on borrowed capital, natural capital. So in summary, we've got an issue where we're going to need more environmental resources to satisfy the needs of more people. We need to distribute those environmental resources more equitably in a changing environment. You know, we have land use changing. We've got the impacts of climate change. And indeed, when we start looking at these global drivers and trends, we see resource stress in the physical environment as being one particular challenge or driver that we've got to overcome. And it affects construction. So if you look at the data in this graph, no surprises, to satisfy developments, creating new towns, cities, building railways, airports, all the things that modern life involves, needs greater construction materials. So our use of construction materials is increasing. But we don't always have control over the supply chains of important materials, which are relevant to us in the built environment. And the point I want to make in this graph is that there's at least 20 raw materials that the European community, and indeed the UK, doesn't have direct control over. But actually, in building infrastructure for us in the future, it's going to be increasingly important that we get access to these materials. So let's just take a couple of examples. Gallium, it's used in electronics for things like microwave circuits, for LED lighting, for diode lasers. Could we live in a world where suddenly there's no gallium for LED, when we're driving all these energy efficiency programs around LED, for example? If you look at some of these other rare earth metals, they're incredibly important. for technologies including advanced transportation, healthcare, scanners, and such like. So the point I'm making here is we've got resource use pressures there, but we've also got very important materials that we've built up a need for in terms of providing solutions. And of course, no surprises, if you're an economist listening in, you'll be starting to think, okay, what's going to be the impact? So we've got to have a gap between what we require and what is available. And that leads to volatility, leads to risks, which are documented in this particular slide. So we've got a crunch point, really. And in addition to that, if you look at what's happened since the year 2000, which is new, is that for every percentage growth in GDP, in other words, our societies are getting better, the actual commodity price is starting to increase, whereas previously, in that period of economic development, it dropped. So increasing population, but actually increasing prices for construction materials is a possibility. So how do we manage that? How do we start to provide the solutions to living in a world with those kind of problems? And of course, it's all compounded by the fact that actually we've got quite a wasteful system already. So in many ways, there's an opportunity to actually look at all of these particular areas. Let's take construction there. So the data there suggesting there's around 10 to 15% of building materials that are actually that are wasted in our system. Likewise, if you go to end of life, 54% of demolition materials are landfilled. So again, really wasteful. Usage is around energy efficiency, and probably we've touched on that, or you know quite a bit about that already. So there is opportunities within our system to improve it around how we design and build for the future, how we think about disposal end of life. So how do we transform what we've got? So the current system is described here, which is one of take, make, and dispose. So we extract various different materials, we put them together, we make something, we then utilize it, but in that manufacture there's waste. And then when we've utilized it, in other words, the consumers, our clients, we then typically waste it, we throw it away. It's not used again. We'll just go back and use the virgin material to go through that cycle again. And that cycle actually is a linear cycle. It's not circular at all. And that's the issue. So what does the circular economy attempt to do? Well, if you read the words on this slide, it's looking really at a situation where waste is banned in our dictionary. It doesn't occur in the lexicon. And if you think about the natural world, there isn't such a thing as waste, because everything gets reused, recycled, or has a use. So even if you remember your work on or your studies on food chains and understanding the nutrient cycle, everything should get reused and recycled. So the circular economy is the principles really. It's about nothing is wasted. Everything can be either reused, remanufactured, recycled, or put back into a productive cycle. And the circular economy is meant to be restorative by design and aims to maximize and utilize the value of those materials all time. And that's quite an important point to make. So you utilize and maximize the value at all times. And I think you'll probably be aware of some examples where we attempt to keep the materials in play, but we don't always maximize the value. So it's not necessarily the best use of those particular materials, but at least we're not completely taking it to waste, wasting it and taking it to landfill. So that's the concept. A couple of key other points to kind of think about is that it's an economic model. And what it tries to do is decouple economic growth and development from the consumption of finite resources. So very much in the same way, we're trying to decouple the climate change or greenhouse gas emissions away from economic development. And this plays a part in that larger equation. It's also important to note it distinguishes between and separates technical and biological mechanisms. And in our presentation today, I think both with Julia's examples, most of what we're going to be talking about is around the technical aspects rather than the biological. And it also focuses on effective design. And I think when you look at it holistically, the way we design our systems and actually how we design to manufacture, for reuse, for disassembly, etc. Design is a fundamental principle that runs all the way through this. So if you were to Google the circular economy, typically you'd get this picture, this schematic. And on the left-hand side, as you look at the slide, that's the biological side of things. That's where I was talking about nutrient flows and ecosystem services. And on the right-hand side, that's the more technical input. And so we start off right at the top with, so where do we get our resources from that we are going to then be using in the built environment? So very simply, if we take a simple supply chain, I don't know, maybe the production and pouring of concrete, well, we'd start up with some very basic ingredients, such as aggregates that would come from a quarry. So they would have to be excavated. Those ingredients in different parts would then go to a product manufacturer. But of course, before we do that, we have to make Portland cement. So we'd have to have a cement kiln, and we would be including sand and silicas and various other things to make the Portland cement. We'd then be in a situation where the cement provider or the concrete pourer would then be on site doing their mixes, which would include the sand, water, and the cement powder, and then that goes into the finished product. And then typically, what would happen after that product has been used? Well, the good news is in construction now, we typically would use that as a secondary material. So we'd crush that concrete and we'd put it back into the system. So you've got a circular economy happening, which would be in the redistribution. It's not typical reuse, but you put it back into the system, so it doesn't get used. So that's what we're attempting to do. So all the way through, whether you're parts manufacturer, product manufacturer, retail service provider, can you get access to the materials to put it back into your system? And of course, when you're the user, you can then go into repairing things. You don't have to then put it back into another system. You can keep it within your own system. And we will no doubt go through some examples in that. So that allows us to start thinking about, in construction, what are the opportunities for managing a system whereby we can incorporate those principles of the circular economy. What I'd like to do is say that in each of these stages, there are economic benefits. Remember I said it's an economic model for how we can reconfigure and redesign our systems around materials. And so if you start to think about it as a management process, wherever you are, whether you're into refurbishing and remanufacturing, whether you're reusing or redistributing material, or whether you're in a period of where you can extend and prolong the life of a product. So for example, instead of demolishing a bridge leading to a whole load of road traffic congestion, then having to use those materials back into redistributing it, you can actually prolong the life of some of these bridges. And I remember when I worked for Balfour Beatty, there were particular polymers you could then inject in multiple bridges that would extend the product life, in other words, the life of that bridge for another 25, 30 years. So wherever you are in the system, you start to think about what would be the economic benefits of actually deploying those principles and maximizing the value of that asset and those materials. So very briefly, if we look at some of those benefits, just in the London environment, up until the period of 2030, there's been an estimated, and the range varies quite a bit, but I'd take 2 billion, I think you would as well, maybe it's up to 4 billion, but opportunities around value creation. Likewise, using the management of building materials to actually understand where those materials are of high value, and how you can then integrate ideas around disassembly. You could have material passports, RFID tagging, etc., reverse logistics. There's a whole load of stuff that can create savings as well. And then actually thinking about construction techniques in the way that we design and construct our buildings, which is all around the modernisation of our sector, for example, around modular, which runs a much tighter control system with the reduction of waste, and also economic benefits around productivity and impacts on health and safety. So there's some clear benefits that have already been described by others in this. So how then do you look at this as an opportunity? So there's Accenture did some research, and this isn't just for construction, it is across the piece around the world. And typically they came up with 5 economic business models. I'm briefly just going to describe them to you. And I think the best way to do that is to move on to the next slide, where you can see the circular economy model again. And so the first business model is really around circular supplies, and that's based on supplying fully renewable, recyclable or biodegradable resources that input into the production and the consumption systems. And this is really most powerful for companies dealing with scarce commodities or ones with a major environmental footprint. So what does that look like in construction? Well, I was thinking probably asphalt, where you can take off the top, sort of plane off the top of asphalt or the bitumen from roads, and you can take that ingredient and you can put it back into the system. Likewise with glass recycling, 2 examples there. And then if you move down into the next business model, which is about resource recovery, so that's where you maximize the value of the material, but it doesn't stay in its existing state or would be used for what it was used for before. So that's a good example of what we were talking about before around aggregates, where you crush your concrete and it becomes a secondary material. So in this model, in the resource recovery, we think about the recovery of the embedded value at one end of the product life cycle to feed into another. So you're converting from one use into another. And this promotes return chains. It transforms waste into value through innovative recycling, take-back schemes, or even upcycling services. So there's a business model there. And then the third business model really is around product life extension. So I gave you that example previously around extending the life of a bridge, but that's when you're into repairing and refurbishing. So this business model allows for companies to extend the life cycle of the products and the assets. And the value would otherwise be lost through wasted materials, but they're maintained instead or even improved by repairing, upgrading or remanufacturing. And then if we move on to the penultimate model, which is the sharing platform, and this is, I guess in a way you could simplify it and say this is all about maybe an eBay system where you've got platforms which allow collaboration amongst product users, either individuals or organizations, where you can facilitate the sharing of the movement of materials to help with overcapacity or underutilization and increasing productivity and user value. So this is all about what you can do to improve ownership rates. And finally, the last business model, is around products as a service. And so you provide an alternative to the traditional model of buy and own. So I think a lot of you will have known the example of everyone goes and buys a drill just to use 3 times over the period of 5 years, and it stays in your garden shed or beneath the stairs. Well, actually, wouldn't it be better if all you want is the service of the power to be able to knock a hole in or drill something? You just want that service, so you don't actually need to own the product. And when you look at that as a model within construction, well, we already see that with plant hire. But actually, when we go into indoor built environment, there are examples of where people say, I just want to buy for the provision of the right kind of lighting at the right levels. the service that you provide is adaptable. And Philips, for example, the Dutch light bulb company, provides such a service to that. So there are examples of that happening in the UK. And moving on, there are now building materials that actually are certified to the cradle for cradle or the circular economy principles. And they cover a whole array and host of different things, whether it's structural things like timber, through to cladding, blocks, facades. I mean, there's a whole variety of different examples here, but each one of them have demonstrated how they deploy the principles of the circular economy. And so if you're after more information, the Ellen MacArthur Foundation and also Cradle to Cradle is a good source, and that book from Essentia that I was telling you about before. And now we've got architects and designers also thinking about these principles of a circular economy, how we can improve the nutrient flow here, going back to that green part rather than just a technical aspect. Also, how it then develops into the quality of life around clean water, beauty, aesthetics, having a positive impact. And here are all examples of cradle to cradle products being used mainly in Europe to deliver those principles. And so I'm sure we're going to hear more examples from BAM. So again, that just brings things to life around how these products have been, in their design, have contributed and delivered to those principles. So there are a number of research programs if you want to find out more information. So for example, there's the Buildings as Material Banks. Here you can find out about materials passports, business models, and indeed BAM are part of that group. So what I'd like to do now is just pass you over to Julia to provide more real life practical examples of what BAM Construct UK have been doing around the circular economy. Thank you.
Thanks very much, Paul. Just bear with us for a few seconds while we hand over to Julia, but I would just quickly say, if you have got any questions, do remember to type those in now and we'll go through them at the end. So without further ado, here we go. Julia, we are now handing over to you.
Great, thanks, Will. I will just show my screen.
Okay, yeah, all good.
Perfect. Good afternoon, everyone, and thanks to Paul for that great overview of the circular economy in the built environment. As you said, I'm going to run through what we've been doing at BAM around the circular economy. But first of all, just a bit of an overview of what we do at BAM. We have a sustainability strategy to have a net positive future. This means having a climate positive, so reducing our emissions to zero and providing products and services which reduce other people's emissions to zero. Being resource positive, so reducing and moving towards zero waste and preserving natural capital over the life cycle of a building. And finally, people positive, so enhancing the lives which we come into contact with and making a difference to the people we work with. And that sort of comes to our overall positive impact on society. And the circular economy fits perfectly, obviously, with the resource positive side of the strategy by maintaining the value of materials through multiple life cycles. But it also has a positive impact on the climate through reduced embodied carbon, and also sort of potentially around the people side of the strategy through opening up new business opportunities for SMEs, and also local businesses may play a key part in a circular economy in the built environment. So BAM have been members of the Circular Economy 100, which is run by the Ellen MacArthur Foundation. They have produced lots of great work around finding out the benefits around circular economy and where the opportunities are. And the C100 brings together lots of different companies, both from the built environment, so companies like Arup and Philips, but also companies from other businesses and industries, so Nike and lots of material manufacturers as well. BAM joined back in 2013 now, so we've been working with them quite closely, and a lot of the work we've done since then has come from conversations and discussions from that group. As Paul mentioned, we're also part of the BAMBI EU research project. So this, as he sort of gave an overview, looks at various kind of issues around creating buildings as material banks, so including things like material passports, and it brings together 15 partners from 7 different European countries. We've also been involved in consultancy work around the circular economy, so helping HS2 look for opportunities within the programme of works to implement circular economy principles, as well as working with the GLA, Greater London Authority, to help assist with the guidance for a circular economy statement as part of their draft London plan. We've done both of those pieces of work in conjunction with Useful Projects Consultancy. We are members of the Supply Chain Sustainability School, so if anyone is after a bit more information, this is a great resource of topics of not just circular economy, but anything to do with sustainability within the supply chain, and there are some modules on there. We have also done some workshops with them, which I'll talk about in a little bit more detail in a minute. We have also been involved in creating production of materials and guidance documents for the industry, and if anyone is interested in them, they're available on the website, or I can potentially send those out at the end of the webinar. And finally, most importantly, we've been involved in projects both in the UK and in the Netherlands, and I'll go into a little bit more detail about those in just a minute. But firstly, what we recognised quite early on is that we really need to work closely with our supply chain if we're going to implement circular economy solutions within the built environment. So we've been running workshops now since around 2016, where we first engaged to host a series of 4 workshops, including a sort of circular economy overview, looking at design, how information technology is going to play a part, and then also business models and how supply chain may need to change or adapt their business models for the circular economy. They were very well attended, and we had various different types of people come along. And since then, we've been in discussions with several of the attendees, including Trox and Armstrong, working on sort of ceiling solutions, as well as Whitecroft, who I'll give an example of what we've been doing with them in just a second. But just to highlight, the diagram there on the slide shows sort of the outcome from those workshops and areas which need a bit more work to allow for real life examples to happen on projects. I really liked the innovation one, which was sort of highlighted during the workshop, that if you're going to put something new to market, if you're going to fail fast and move on to the next idea. So keep that rapid prototyping moving forward and onwards to the next best thing. But the example which I'm going to bring up, which we've managed to do from those workshops, is Cheshire Police HQ. So this is a project which was built by BAM back in 2003. It's a building of 23,000 metres squared, accommodates over 1,000 personnel in that building, with more than 50 types of department, including sort of vehicle maintenance areas, training areas, armed response units. There is a big central open air courtyard with water features and social areas. There is 4 different wings, and then there's extensive sports and recreational facilities in there, including sort of gymnasium, sports hall and restaurant. So it's a real mix of function, which means that there's lots of different environments and functions which we need to accommodate for in that building. So we built that back in 2003, and we have an ongoing relationship with the Cheshire Police, and BAM FM manage that building. So, 2003 is 15 years old now, and we recognise the lighting in there needed an upgrade. It's 15 years old, and it's the old fluorescent tube ballast type of lighting. The areas, some of the areas have changed function and have different uses now, as well as there was some feedback that staff members were getting headaches, probably from the lighting and the change of function not being quite correct. So we decided that as we knew exactly where these lights had come from, we would go back to the supplier and see what was possible with this upgrade. So Whitecroft Lighting were the lighting manufacturers, and they were able to suggest putting in organic controls. This would sort of create the energy efficiency side of the project, so improve energy savings by about 67%, and create really adaptable workspaces. The organic controls would allow for reaction to the occupancy and daylight being sensed by a detector, and this would transmit data to nearby luminaires to either push that reaction, similar reaction if that's the kind of output which was required for that room. So this is great, but we obviously have this mandate at BAM around circular economy, so we sort of said, what can you do? And the first option which they came up was using their EcoPack reusable packaging system. So in the centre there, you can see that there's cardboard and polythene, which is the usual kind of materials which lights will get delivered in. It fills up a lot of skips very quickly, and obviously creates a lot of material with a single use effectively. But what Whitecroft can offer on the right-hand side there is a reusable packaging system, which gets delivered to site in that box, which can then collapse, stored on site until the next delivery, and then that box is taken back to the manufacturer. So that was an obvious no-brainer for us, and we said, yes, we'd definitely like your EcoPack packaging, but is there anything else we can do? We know we've got these old light fittings of yours within the building. Can we explore what's stopping us from reusing them? So Whitecroft agreed to take back 3 of the light fittings, and they sort of took them apart and decided to see how we could retrofit these old light fittings. And we were all pleasantly surprised when we realised that the new technology could be put into these old light fittings, so the brand new LED technology that is. They could reuse the casing and also the flying leads, which is the wiring at the back of the lights. Directly, there's no issues around that. It was only the marshalling box, which is the control centre of the light, which couldn't be reused. And this is due to the size of that box, and having that increased organic response wouldn't be possible to reuse that box. So we worked very closely with Cheshire Police HQ. We worked with Whitecroft and then also Gibson and Ryan, who are the SME who are going to install and deinstall the light fittings, to identify areas of the building where it would be possible to reuse these retrofitted lights. And what we found was that there was around 200 to 250 lights which we could take back, and we're currently in the process of getting them retrofitted with the brand new the LED technology, and they'll go back directly in the building. And then in other areas where we need that increased functionality, the new light fittings will go in. It was actually cheaper for us to produce these retrofitted lights, which is obviously a big win, because that's often seen as a barrier that may be a bigger expense towards reusing these lights. And we were also offered a same warranty for the old light fittings as the new light fittings from Whitecroft. So again, that's often seen as a barrier to reusing materials which are in a building. But because Whitecroft were quite confident of what was in the material, where it had been, what's happened to it, they were able to offer that to us. So that's currently an ongoing project. That install is just happening now. But it was a nice win from these workshops to then find a real life project where we could put these principles into action. The next example we're going to talk about is the circular pavilion. So this was very much an experiment which was developed by Arup, Brainer and Riper, and the Built Environment Trust. And it was a prototype to explore how the industry can work towards a zero waste future. So it was very much about collaborative working and developing the concept about being transparent with what we can achieve around designing a building for circular economy. So the idea of this pavilion is that in theory, it can all be taken down and put up again elsewhere based on the design. So to demonstrate what was done, I'm going to use Frank Duffy, the 6 S's, which was later adapted by Stuart Brand, the architect. So first of all, you have site. So this is all about the location of the building. I mean, on this example, we were only there for 2 weeks, so the site was meant to just be central London, where it could get a lot of publicity and also be accessible to people. But in terms of circular economy, you really need to be thinking about your infrastructure and whether it is adaptable for increased function later down the line, and what is there currently and how it needs to be adapted if there is a change of function in the future. Next up, you have the structure. So this, for the circular building, was designed to be demountable and reusable. So the steel work was made from offcuts from another project. The size of the building was adjusted slightly to suit the size of those offcuts which are available. The steel work is all bolted together, so there's no welding. So this means that we could take it apart and put it together again at a later date. The skin of the project is generally around a 15 to 60 year cycle, and it was got a very functional purpose of protecting the structure, but also an aesthetic value to it as well. So what we used here was the cradle-to-cradle certified cladding, timber rain screen cladding, which Paul mentioned earlier about cradle-to-cradle. The walls internally, well, and externally actually, were used from wiki panels. So these are boards made from agricultural waste. So the material can be reused at the end of life and put directly back into the manufacturing process. It's bonded with natural resins and is assembled with screws and push bit connections, so it could be taken apart and again put together at a later date. The roof lights can be removed in one piece and in theory resold as new units. There shouldn't be any change to them from being within the building. And the glazing was uncoated glass, which improves its recyclability. And both the rain waterproofing layer and the curtain walling system use no adhesives or site-applied sealants. So again, facilitating that deconstruction at the end of the building's life. Services, this was, again, it's a very small prototype example. So there was limited services which were required. But in this case, Arup actually designed the mechanical ventilation and heat recovery unit from recycled plastic and reused drinks cans and a refurbished electric scooter. Obviously that can't be scaled up in a big project, but it was just to test to see what they could do on a small scale. Space, normally around 3 to 7 years, so a much shorter lifespan, and it's therefore more important to have sort of non-load bearing walls which delineate space used within the structure, so that in theory you can change the way the space is organised at a later date to change as the function does. And finally, the stuff. This is the things you find in a building which will change quite frequently. So it's the furniture, appliances and personal items all fall into this category. And on this next slide, there's a few examples of what we did around that. So with the stuff, there's things like the task chair there from Orange Box, where components can be easily replaced or repaired and upcycled at the end of life. So if in theory the handle of the chair goes, instead of replacing the whole chair, you can just replace the handle. Other examples on there of things which went in was the gator duct cardboard ductwork at the top instead of your sort of metal ductwork, which is quite a lot more carbon intensive. There is the Ortex wall finishing, which is made from recycled plastic and itself is totally recyclable as well. And finally, also the cradle-to-cradle mislay floor tiles. So a real mix. And there is a website which Arup have produced, which goes into a lot more detail about what went into the building if you're invested in finding out a bit more. Just check how long is the time. I'll just briefly go into two of our Dutch projects, which again have sort of circular economy ethos at their heart. So the first one is the Cirque Pavilion, which was built for ABN AMRO, the bank. Originally, when this project was put forward, it didn't have a circular economy design, but once BAM were appointed, we kind of put the concept forward to the architect, who really bought into it as soon as we sort of had those discussions with them. And ABN AMRO now have a very strong commitment and interest in seeing the life cycle value of those materials within that building. The design is modular. Lots of prefabrication was used, and it was that the idea was to again make sure that the demountability was available at the end of life, and they reused materials wherever possible. So they looked at using urban mining specialist New Horizon, who were able to source different reused materials from other projects as well. There was early contractor engagement with the supply chain to make sure that we could incorporate sort of supplier take and buy back contracts, as well as talking about residual value during those early discussions. The windows in one of the meeting rooms are taken from an old Phillips building, and as you can see, can sort of look like a nice, stylish, modern-looking space to create those different areas within the building. Timber beams, so these were made a little bit thicker than was necessary so that could increase the residual value at the end of the building's life. And again, we used larch wood, not only because it was more local, so had reduced CO2 emissions from transport, but also because larch wood tends to have a better resale value than alternatives such as pine. And it also looks lovely in the building. When this was put together, the design of that timber was based on no screws, on no nails being used, but all screws, and we thought about how to put it together to minimize the amount of screws as well. You can also see on that image there the cable ductwork, which was salvaged from another property and brought to this site for reuse rather than going for recycling. Within the space itself, there's movable partitions to make the space really flexible and to reduce the amount of time when it's not being used. So the idea is that in theory it could be a pop-up cinema one night, and the next day it could be a pop-up shop in another space, so that we had these sort of movable partitions to change the way that space is laid out. They also incorporated other parts of the bank and tried to keep some of that feeling and place of the bank by reincorporating items from there. So this included the lockers, the old lockers from the building. And then externally, they included, tried to make it reuse lots of renewables. So in this case, there was high efficiency solar panels from the Netherlands, which had a guaranteed longer lifespan and were set on the roof. These are the wall panels, but there were some on the roof as well, which were set on recycled paving stones and ballast from which were on the building's space at the start. And then on the top, there are herbs which are grown and sold and used in the restaurant. The demountable facade is made of recycled aluminium, and both the green wall and the planters on the building can be detached and reused again at the end of life. And I'll just check I've got time. I'll go through this one very quickly. So this is transformation of Broadplatz. It's for Rural Haskening building, and it was an old car showroom building, which you can see there on the image. And the idea was to create a flexible office space where there was some which were for the Royal Haskening themselves, but then there was meant to be a lot of community desk space which could be used on the building by different local community projects. So what they did was partnered with New Horizon again to reclaim valuable materials and fitted the building out. So that has included the ductwork, which I talked about earlier, but also the ducting. There was an investor-led approach for this, so it was very much focusing on residual value at the end of the building's life and using it as a catalyst for creating that circular building idea. And the idea is that there's fixed rates for which are paid over a period of 10 years. Now, at the end of that time, the materials can either be reused or the lease can be renewed itself and continued. So that's it from me of a few examples of what we've been doing at BAM. But I'll pass back over to Will to go to the next section.
Thanks very much, Julia. That's excellent. Now's the time, if you have them, if you have one, to ask a question. Invite sort of Julia and Paul to answer those. We have had one question, so while I take back the webinar. I will read out this question. It's from Charlie Henry Smith. He says, a question for Julia. Would you be able to explain your experiences with recycling concrete and how the circular economy might be applied to the foundation of a building? So that's a question from Charlie. That's the only one we've had so far. If you have, if anyone listening has any more, we do have a couple of minutes now. Julia, did you hear that?
Yep. So I personally, I've not been involved with much of that myself, but I do know our Dutch colleagues over the Netherlands are looking at this quite closely because they're currently working on a new project where they are looking to reuse, I think it's around 98% of the materials currently at the site, and there is concrete there, and they're currently looking at the process for sort of taking that concrete, grinding it down and reusing it, but I'm afraid I can't give you any more details than that, but I can endeavour to find out and get back to you at a later date.
Okay, thank you. Let's see if there's, oh, yep, we've had another one just come in. So this, just 1 second, sorry. Right. Question from Anna Vega. It's not directed to anyone in particular, so I'll address this to both our speakers. Does this mean there will be some materials we should not use, e.g. FRP stroke GRP for structures cannot be recycled and is hard to reuse unless modular with lots of connections? Will we actually favour steel for major structures as it is easier to reuse? And that's a question from Anna Vega.
Sorry, can you hear me?
Yeah, I can hear you, Julia, yeah.
Yep. I guess in our experience where we've had a circular kind of push on a project, it's tended to be a steel structure due to the fact that you can design it so that you can take it apart at the end of life and reuse them directly. But we are also looking at timber as a way to be able to it's rejuvenating itself, but also be reusable at the end of the life. And again, that's in that example with ABN AMRO, the timber was made of a slightly thicker kind of, so that at the end of the life, the manufacturer would be able to take it back and resell it rather than having any issues structurally around that. So yes and no. I'd also say it's a case-by-case basis at the minute in terms of looking at the design of a building and seeing what kind of circular solutions would apply to it. And it might be that for one building, it's that whole, looking at the whole lifespan of it, but actually the other aspect of this is looking at when there is a building already there, a concrete structure actually means it's very long lasting, and if you can then refurbish it because of that, it makes it easier for that building to be refurbished potentially.
If I might add something, Julia, and it relates also back to the last question around foundations. So the big challenge, particularly with steel, is around understanding the provenance, how it's being used, and what kind of warranty that you could put on the steel if you were to reuse it. But there's quite a lot of research that's going on at the moment into the tagging of steel, how the steel would then be put into a bin, and this relates to materials passports really. But until we understand that, then typically the piling and the steels would go back into the system, and it would be recycled. And as you know, well over 80% of most of steel used in construction is recycled. But for it to be used in terms of a product extension, you need to overcome those types of issues I've just described. So really understanding the provenance, the use, and therefore how that impacts on the warranty. And that's research that's been conducted by some of the steel fabricators at the moment.
Okay, a couple of questions around metrics and measuring things. It says, does BAM have any metrics or targets that help you measure progress towards circularity? And how do you measure residual value? That's from Eleanor King and Matthew O'Leary.
So with the residual value examples we mentioned in those other projects, it's very much working closely with the suppliers at the moment and asking them in theory to take it back or to reuse it in the future. What are their requirements? So again, that came into making sure we're having those discussions about thickness of timber or whatever it may be, and then speaking with them to understand what the current value of second-hand material, if you want to call it that, is in the current market, and how they see it changing. There is no hard and fast way. I do know there's sort of several people looking at indicators for circular economy and ways you can effectively measure a circular building, but it is very much at the minute exploring with the supply chain what we can do.
Okay, thank you. That's it on the questions. I'll give people sort of one more minute in case there are any last minute thoughts. And while we're doing that, I'll just remind you again of those events. If anybody listening is interested in coming to those, it should be informative and interesting events on the 12th of November and the 22nd of November. And I can't see that we've got any more. So I think we're pretty much bang on the hour. So I'll just say a big thank you to Paul and to Julia for today's presentations. If anybody does have any more questions that they would like to direct at the speakers, I'm happy to, we can circulate an email address, for a Syria email address, and we're happy to pass those on. Yes, thank you very much, Paul. Thank you very much, Julia, for your presentations today.
No problem.
Thank you.
Okay, thanks, everyone. Goodbye.